Welcome to Study Loop.
Okay, we have two molecules. Okay, we've got a phenyl ring with a methoxy and bromoethane. And it turns out that both of these molecules have a mass to charge ratio for the parent ion of about 108. And the question is, how can we differentiate them using low resolution MS? Well, recall the trick that we're going to use here is that bromine always has a special pattern in mass spectrometry. And the reason for that is that, well, what is the molecular weight of bromine? Do you recall? It's about 80, right? But there is no isotope of bromine 80. It does not exist. DNE does not exist because it turns out bromine is actually comprised of bromine 81 and bromine 79 in 50% proportions, right? So half of all bromine is bromine 81 and half of all bromine is bromine 79, which means we're not going to get a peak at 108, despite the fact that the molecular weight of this molecule suggests that it would have a peak at 108, right? Because what we're going to end up with is not a bunch of carbons and hydrogens and a bromine that weighs 80. We're going to end up with either bromine 79 on the molecule or bromine 81 on the molecule, which means we're going to get a peak at 107 and a peak at 109. And furthermore, these peaks will be roughly equal height, right? Because of the 50-50 split. And so we'll have a missing, like no peak here. Or if there is anything, it'll be very, very tiny owing to other isotopes of carbon, right? And yeah, that's the answer, right? You can use the M+2 peak due to the two isotopes of bromine. That's the final answer. You can use the M+2 peak due to the two isotopes of bromine.